Alright guys, so I've already made a video on this eco-worthy 1000 watt 55 amp inverter charger, but I want to make a video explaining how I built this and what is the benefit of building one of these comparing it to buying one of these. So this, just right off the bat, both of these I paid for with my own money. I paid $500 for this. Where, depending on where you get it, you can get it anywhere from $500 to $800. If you want to expand the battery, that battery is also like $500. And this is a 1056 watt hours. And the way this is, you measure watt hours is you get 1 watt for every 1 watt hour. Okay, so when you buy one of these, there really isn't much you can do. You can expand the battery with this proprietary battery, but there are hacks on how you can expand the batteries with one of these lithium iron phosphate batteries by plugging it into this port right here. Okay, so let's get back to this one. So the way this one is built, I have a couple breakers here, and this is to protect this system. I have a eco-worthy, this one I think is a 30 amp eco-worthy charge controller, and it is a PWM. I do want to switch this one out to a MPPT because it's a better technology, but this is the one that I have, and this is the one that I used for 2 years already with this system. So you know, it's been working fine, but I do want to upgrade this. So the way this is set up, from the charge controller, I have a power to a 50 amp breaker fuse. I can lower this, but I don't know if I'm going to lower it yet to a 40 amp, just because I do want to change this out. So I'd rather have the 50 amp, and it's off right now. I can just turn this on right there, and you see it clicks on. It's fully charged. So as you can see, nothing is drawing on it because it's fully charged. And then I just hit this one to turn it back off, and that's it. So that breaker is connected to the battery right here, and then from the battery to the inverter, I have a 2-gauge wire going up to a 200 amp fuse breaker, and then back down into the inverter. And the reason why I have a 200 amp fuse breaker is because this battery, this is an eco-worthy 1000, sorry about that. This is an eco-worthy 150 amp hour battery. What that equates to is 1920 watt hours. And the reason why I have this breaker is because this battery has the potential to, you can draw 180 amps out of this with an inverter. Now this inverter particularly is not going to draw that much, just because it's a 1000 watt inverter. But you know, just to safeguard it, I added a 200 amp fuse. This breaker is used for my solar panels. That's the wire to the solar panels right there. And I have two 300 watt solar panels. This charge controller can only take 400 watts, if I'm not mistaken, or 450 watts. I have to really check it, but I think, if I remember correctly, this only accepts you can only put 400 watts of panel on that. And this breaker is only for the solar, so we can turn everything off. And you know, if there's any issues, you can turn all the breakers off, and everything is off right now. There is nothing being drawn out of this breaker, out of this power station, sorry. And the benefits to building your own power station is that, so I have an eco-worthy 150 amp hour battery here. If I want, I can expand this battery, meaning I can put multiple batteries in this in parallel, not series, because this is 12 volt. I can do 23 volts, 24 volts with this, but I leave it at 12 volts. And that's one of the benefits. Another benefit is that compared to this, if something goes wrong with this, where you have to send this to get fixed, you're gonna pay a lot of money to get this fixed, believe it or not. If the inverter goes bad or the charger goes bad, anything goes bad on this, you're gonna pay to get this fixed, believe it or not. And good luck finding someone, unless you're sending it back to the company. Good luck finding someone that can actually work on that. Now this is the Anker Solix C1000. This is an 1800 watt battery station or power station. With this, you can diagnose it yourself. Let's say your charge controller goes bad. Well, you can just swap this out, unscrew it, and drop in a new one. Let's say your inverter goes bad. Well, you can take the inverter out, drop in a new one. These batteries are good for 10 years, 10 plus years. With proper maintenance, you can get 15, 20 years out of one of these batteries. The battery technology nowadays have gone, through the roof, man. The technology is awesome with these things. So that's a benefit, because as I said, if that goes bad, good luck finding someone that can work on it. That is still under warranty, so I would just send it to the company. But once it's out of warranty, good luck finding someone to fix it, or if you send it back to the company, you're gonna pay for it. I'm not saying that that's a bad choice. Obviously, I have one. I paid for it, and I love this thing. I take this thing camping. It's very, very portable. It's about 28 pounds, give or take, and it's worked flawlessly for what I use it for. When the power goes out, I also use it to power a couple TVs, just like this one. So, but that is the benefit of building your own. And again, if you don't want to build one of these, or if you want to build one of these, there are many videos on YouTube that you can find. I can one day, make another one and also put it on YouTube. I don't have any bus bars on this because, as I said, I only have a few items here. I don't have anything on the outside of the box, which I do want to add one day. Maybe a 12-volt socket, maybe some USB-C ports and stuff. So I'll have to add a DC fuse box here, and some stuff to do that. And maybe later on down the line, I will add some bus bars, just so I don't have to put two wires on one lug. That's the benefit of having bus bars, that you can put one wire to a lug and cinch it down. But yeah, there you go. That's a benefit of building your own, that you can diagnose it yourself, and you can fix it yourself with no problems. So yeah, and that's how I built mine. And it's very simple, as I said before. Very, very simple. You just have to be careful gauging your wires. Make sure you get the correct gauge wires, because you don't want to overheat the wires, have them melt, because those things do happen. So make sure you do your research, gauge your wires correctly. Something like this, I always go with number 2s. These are number 2 gauge. Let me see where I can find it. Right there. These are 2 gauge wire, up to 300 amps. So just to play it safe, that's what I use all the time. If I build one, let's say with the 2000 watt that I'm going to build on this one down here, I'm going to drop that down to a 1.0, wire, just so the current can be proper. All right. So that's today's video. Catch you guys on the next one.